Hello everyone and welcome to this new Unreal Engine 5.6 tutorial. In this video, I will show you how to create a Levitate spell to literally lift any object you like, just like in Harry Potter. This tutorial will be based on physics and physics objects, and it works with literally any object that has a primitive component as the root component. Okay, for example, these static meshes are pure static meshes and have a root component as a primitive component, so I can lift them easily, as you can see. And this skeletal mesh is also a primitive component, so I can lift it as well. And this actor that I had from before is the interactable. If you follow my interaction system, this has a static mesh as the root component, so I can also lift it as well. So if you want to learn how to do it, please stick around and watch the video. So first thing we need to do is to create our crosshair. So let's import the crosshair image. I will leave a link in the description for this if you want to use it, or you can have your own custom one. Then let's go to blueprints and widgets and create a new widget. Now, if you already have one, that's okay, you can use it, but I don't have one, so let's create one for the HUD. And in here, let's add a canvas panel, then an image, and let's center the image and give it an alignment of 0.5 and size to content true. Then let's set the image to be the crosshair. Let's resize it to 100, 100. Okay, now let's go into our player controller. If you don't have one, go ahead and create one by choosing a blueprint class of type player controller. Then go to edit project settings, maps and modes, then player controller class, and set your player controller class here. Once you do that, open it, and inside the begin play, we need to create the widget. So create widget, owning player itself, and the class is the one we just created, and let's add it, not promote variable, let's add it to viewport. Great. Now, if we start the game, as we can see, the widget is here, the crosshair is visible, but it's in the center and the player is blocking it. So let's give an offset to the player, to the left. So go inside your player controller class, inside your player character class, and click on camera boom. Then for the socket offset, I'm going to choose on 50 on the y-axis, and for the z, I'm going to choose 70. Then for the target arm length, I'm going to choose 225. Now you can do it as however you like. I just like how it looks right now. Okay, great. Now let's head back to our player controller class, and we need to create a function here that will do a trace from our camera straight to the crosshair. So wherever we are aiming, it does a trace to that. Okay, so let's create a function called line trace to crosshair, and in here it takes a parameter of type float trace distance. Then let's get the player viewpoint and make a line trace by channel, and channel is visibility. And for the start, let's plug the location, and for the end, let's get the forward vector of the rotation times the trace distance plus the start, which is location, and plug it into the end. And actors to ignore, let's get the controlled phone and plug it here to make an array. And for the debug, let's make it persistent for now. And for the return node, we want to return the hit. Okay, now let's test this out. Let's go inside our character class, and on left mouse button, let's get the controller cast to our controller and call this function. This is only for testing, and trace distance is 1000. Now if I click left mouse, as you can see, it's making a trace where I'm aiming. Okay, great. Let's remove this, we don't need it anymore, and let's remove this draw debug type to none. Now let's go ahead and create our Levitate spell. So let's first create a folder that holds all the spells, and let's create a blueprint class of type object. and let's call it BP underscore spells base. This is the base parent, the base class for all the spells. And then here we need three functions: start casting, stop casting, and ongoing cast. This will be called only once when we start the cast, and this will be called once when we stop the cast, and this will be called every time you are holding the button. As long as you are holding button, this will be called. So first, let's go into our start casting and give it a parameter, and this parameter is our character. Let's call it caster. Okay. Now also let's create a variable. Let's call it spell name. Great. Now let's close this and create a child from this, and let's call it BP Levitate. And for the spell name, let's call it Levitate. And for the functions, let's override these three functions. First, we need to promote this to a variable. Let's give it a category of references. Then we check if it's valid. If it's not valid, we return. We quit early. But if it's valid, we need to get the player controller. So let's get the caster, get controller, cast to third person player controller, and on cast fail, let's return, and on succeeded, let's promote this to a variable. Let's call it player controller. Then from here, let's make a line trace to Crosshair, and trace distance is a variable, so let's promote it to a variable, category parameters, and this value of default value of 800. Then let's break this hit. Let's check if we hit something. If not, let's return. If we did hit something, we need to check, do another branch. We need to check if this hit actor has a tag. Actor has tag, and the tag is Levitate. It can be anything you want, but for me, I want to make it levitatable. If not, let's return. If it has this tag, we need to get the hit component, the root component of the actor. So get root component and cast to primitive component. Let's make another branch. If cast is succeeded, we need to promote this to a variable. Let's call it levitated object. And if false, let's return. So the reason we are casting to the primitive component is because this function will only work, the levitate will only work for actors that has a root component as a primitive component as a root component. So primitive components include static meshes, skeletal meshes, sphere components, capsule components, box components, and such, and so on. Now, if it has a scene component, this will return fail, and the end function will exit, and we will never be able to levitate, because scene components don't really have physics, and you are using physics to levitate the objects. So it has to be a primitive component, most likely a static mesh or skeletal mesh. Okay. Now, let's get the caster. Then let's set the rotation use controller rotation yo to true. Then get the character movement. Set rotation, set orient rotation to movement to false. This is, let's leave it to false. But before, we need to set the controller use control desired rotation to true. Okay, then this is optional. All of this is optional. You don't have to do it if your game doesn't fit this type of change. You can just ignore this. But for me, I would like to do it, and I also want to set max walk speed to 300 because my max walk speed is 600 by default. So I want to set it to 300. Then we need to get the levitated object and set mobility to movable, set collision enabled, physics only, then set the, now this could be query and physics, it doesn't matter. I'm going to set it physics only. Then set simulate physics to true, but before let's set enable gravity to false. Okay, so that's it for the start casting. Now let's close this. Let's go to stop casting. Now let's get the caster and everything we did here in the start casting. In here, we need to change it back. So false, false, true, 600. Okay, then get the related object and set collision enabled, query and physics, set enable gravity, true, and we need to invalidate it. So give it a null pointer. Okay, because we dropped this object, we are not levitating anymore. We need to set it as empty. Next, inside the ongoing cast, we need to get the caster, the player controller, and the levitated object. We need to check if it's valid for all of them. And let's make a branch and boolean. Now, if one of them is not valid, we simply return. Then we get the player controller, line, trace to crosshair. Trace distance is this one. Let's break this. And in here, we need to create a couple of variables. First variable is the current velocity. So get physics linear velocity and promote this to a variable, the local variable. Let's call it current velocity. Then the second one is the current location. So get word location. Oops, get word location. Let's promote it to a local variable, current location. Then we need to get the target location. So we get this by subtracting current. No, sorry. The target location is actually the trace end. So let's promote this to a variable. So and call it target location. So where the line trace ends, this is the target location, where the object should go. Now the direction. So for the direction, we subtract the target location and the current location and promote this to a variable called direction. And finally, we add the force to the levitated object. And the force we want to add is calculated like so. It's calculated direction times a float. And the float, we need to promote it to a variable called spring strength. And let's give it a default value of 2500 minus the current velocity times another float. Let's promote it to a variable and call it damping. Default value of 5 or 800. Okay, and plug this inside force. Now let me explain these two variables. The spring strength is responsible. It controls how strong the object is pulled toward the target location. So a higher value means the object accelerates faster towards the crosshair. Okay, so it's basically how fast the object goes to the target location. And the damping, it reduces the object velocity over time to prevent overshooting or jitter effect on the screen. It prevents if this is like a very low value, the object will act like it's orbiting very fast. It's like a very bad effect, right? So a higher value slows the object down more aggressively, faster. It's like it gives it resistance, air resistance or friction. Okay. Now I will show you an example with a very very low value to see what I mean. But for now, let's get this inside parameters. And I think we're done here. Let's close this and let's create an input. Let's create an input to request the spell. So go to input, actions, and create an input action. Let's call it IA underscore cast spells. And then here, just leave everything as it is. Then inside the IMC, add this mapping, cast spells, and give it whatever button you want. Now let's go to our player controller, player character, and in here, before we call the IA cast spells, we need to override the possess on possess, and whenever we start the game, whenever we are possessed, we need to do a few things first. So first thing we need to do is to teach our character how to use this Levitate spell. Okay, so for me, I want to make sure he knows it by default when we start the game. For you, you might want to learn from a trainer or buy it with coins or whatever. But for me, I just want to have it by default for this example. So in order to teach the player any spell at any time, we need to create a function for this. But before, we need to create a few variables. So first variable is default spells, and it has a type of BP spells, spell base, and class reference. Okay, category spells, and make it an array. And by default, let's give it the spell base. Sorry, not spell base, the levitate spell. Then we need to create a function. Let's call it learn spell. So now you can call this function anytime you want to make the player learn a new spell, and the spell to learn is a parameter. So let's make a parameter of type B spell base and class reference. Let's call it spell to learn. First, we need to check if this is a valid class. If no, just return. And if it is a valid class, we need to construct object from class, and the class is spells, this class, spell to learn, the parameter, and the outer is self. Then let's promote this to a variable, or no, let's not promote this, let's add this to an array, add unique to an array, and promote the array to a variable, and let's call it spells known. Okay. Next, when on possessed, for me, I want to make sure that this whatever we have here are included in this spells based array, because now if we try to add default values, it says no result, right? So when we possess, we need to make sure everything in here goes in here. So for that reason, let's make a for loop and pass this default spell as the array. And for each default spell, we need to call the learn spell function. Okay, and now for each one in here, we will create an object and we will be adding it to this array. And on completed, I want to get a copy of this array at the index 0 and promote this to a variable called currently selected spell. So by default, the first spell in this array is the currently selected spell. So when we press the spell button, cast spell button, this spell will be casted. Okay, now let's call the cast spells IA and get the currently selected spell. And on triggered, we will call the ongoing cast because it's called as long as we are holding the button. So let's call ongoing cast. And for started, let's call this is called once, so let's call the start casting and the caster itself. And for the cancel and completed, let's call the stop casting. Okay, and here let's also print the spell name. Okay, so this should work. Let's test this out. First, let's add a static mesh in our scene. So let's filter this to show static meshes. And let's add this couch. Let's add this table. Let's add this. Maybe this. Let's also add a skeletal mesh, or let's add this skeletal mesh here. And now for all of these, let's give them a tag. So select all of these, look for tag in here, and click plus and click Levitate. It should be the same tag you created. It should be the same name here as here. Okay. So now, and also make sure that the collision for each one is set to block on the visibility channel. Okay, and also make sure that the static mesh itself has a collision. So go inside of it and look for simple collision, and make sure this is here. This capsule is visible. And for the collision complexity, make sure it's project default, because if it's complex collision, physics will not work. It needs to be a simple collision. So now let's try this out. If I aim at this and try to lift it, as you can see, it says levitate, and I'm levitating it. Now you can notice that the rotation is the item is rotating a lot, and that's because the angular, this damping is set to 0. Now if you make it like 2, for example, the rotation will slow down, as you can see. Let's test this for this. As you can see, it's also working, and you can see he's setting he has physics enabled, so he's ragdolling. Oops, he went straight into the ground. Okay. Now, as you can see, this rotation is rotating a lot because the angular damping is 0. Now, you can set it through code if you want all your items to have low rotation rate. In here, you can just do something like this: set angular damping, and whatever value you want to set, you can set it. Or you can set it in here. Each one will have a different value. Okay, it also works for actors, for blueprints that you already have in your game, but it has to have a root component as a primitive component as a root component. So this actor that I have is from an older tutorial. It's an interactable, and it has a root component of static mesh, which is a primitive component. So that's why it's working. But I will give you an example. Let's say we have an actor, and default scene root is the root component. So let's add a static mesh or sphere, no, not sphere, sphere collision, and let's make it visible in game. And let's give it a static mesh also. Okay, let's make this 100. Static mesh, anything. Okay, now let's drag it here. Let's give it a tag. Yeah, so as you can see, it's not being lifted because the default in here, the default root component, the root component is scene component. So when you cast to primitive component, it's returning false, and the function is quit exiting. So let's add a print here. So cast failed, for example. Now you should get, but first, let's remove this. We don't need it anymore. Now we should get cast failed. As you can see, cast failed because the root component is not a primitive component. In order for this to work, we need to make this as the root component, the sphere, or the static mesh. It doesn't really matter. Now it will work, but yeah, as you can see now it's working perfectly fine. Also, it works if we make the sphere as the root component. As you can see. Okay, now I want to show you one last thing. I want to show you what if we increase or decrease these values. So damping, let's set it to 0. I want to show you what happens. And as you can see, it's orbiting around the crosshair. It has a very weird effect. So the higher the value, the better, the smoother the effect will be. Okay, so 800 is good. And for this one, how fast it is, let's set it to 10,000, for example, and it will become very fast, as you can see. Okay, so you can play with this value however you like. So yeah, I think that's it for the tutorial. I hope you've enjoyed it. I hope you've learned something. And don't forget to like, comment, and subscribe. And I will see you in the next video. But before I leave, I want to show you something. Maybe it helps you. Inside my third-person character, I want to remove this. Okay, let's disconnect this, and I want to learn the Levitate spell by interacting with an interactable, for example. So I already have this, so I will edit this and handle interaction in here. I want to get the character, and no, this is the interactable space. Sorry, I want the door interactable actually. So interactable door in here. So on handle interaction, I want to learn spell, and the spell is spell space. Then I want to set the current selected spell. Okay, so this could actually return a value. Let's make this return a spell base of type object and spell learned. Okay, let's duplicate this here. Spell learned is null, and here let's connect this. Okay, now here let's set this here like this, or you could just do it. You could just remove all of this and immediately set the currently selected spell like this without the return. I think it's better, yeah. Let's refresh this and remove this. Okay, great. Now, if we start the game and we try to lift, it doesn't work because the selected spell is not learned yet. So if you go here and open the door and you try to lift now, it also doesn't work. And that's because I passed the wrong parameter here. Let's pass the Levitate spell. Let's try it again. If I try to lift, nothing works. If I open the door and I lift, it works because I learned the spell. Okay, so that's it, guys. Now you know how to levitate any object, any physics object you want, as long as it has a primitive component as the root component. So thank you for watching. Don't forget to comment, like, and subscribe, and I will see you in the next part. Take care.